Throughout Earth's vast history, the seas have often been perceived as treacherous realms, teeming with formidable predators. Yet, there was a singular time in history when the waters were safer than the land, a time when the oceans offered sanctuary, a better chance for survival than the lands. Approximately 260 million years ago, when the Earth was unrecognizable. The time, during the late Permian period, when the Moon orbited closer to the Earth. Earth's landmass coalesced into the supercontinent Pangaea. This is when Africa, the Americas, Australia, India, Antarctica, and parts of Europe, being all connected. This vast landmass was dominated by arid deserts and extreme climates. The waters covered 60% more than it ever had before or after this time period. Imagine an ocean double the size of the Pacific. Even though its large size, the ocean was relatively tame. Yes, it had some shark species that had evolved 200 million or so years earlier, like the helicoprion, that is estimated to have been almost 25 feet in length. These sharks would have been harmless to us. It is believed that they liked soft animals like squids, not bony prey. Today, we still have some of its living relatives today, though not as large, around 6 to 7 feet. Simultaneously, the Postosuchus, a crocodile-like reptile, stalked its prey with stealth and precision, further amplifying the dangers of terrestrial life. Once caught, the herbivores would have been no match for the gorgonopsids' sharp 6-inch, long, curved canines. Definitely, you did not want to run into this apex predator. It is unconfirmed though many of this large gorgonopsid were prowling the lands at this time, but in my opinion, one giant gorgonopsid was plenty. The late Permian was home to many other gorgonopsid species, many which lived in the European part of Russia, as many other parts, meaning the gorgonopsids had complete dominance over many of the vast ecosystems where herbivores roamed, meaning no matter where the herbivores were, they had a gorgonopsids as a top predator. In the south of Africa was a whole subgroup of giant gorgonopsids that had evolved alongside the Inus transavia. The Inus transavia was the largest of the gorgonopsid family. The skulls lacked the peritoneoid bone. They had the ability to replenish teeth. The teeth were serrated, making them better for cutting. They are said to have been 10 feet in length and a sturdy, stocky body. This size alone with those teeth definitely made them an apex predator. That goes to say this was truly the time of the land of the gorgonopsids. With them dominating the land, no wonder the water was the safer choice. In stark contrast, the aquatic environments of the time provided relative safety. Early amphibians, such as Diplocaulus, with its distinctive boomerang-shaped head, thrived in freshwater habitats, navigating the waters with ease and evading the threats that dominated the land. The oceans, though home to their own predators, lacked the sheer ferocity of their land-based counterparts during this period. Species like the Dunkleosteus, an armored fish with a powerful bite, were formidable, but did not pose the ubiquitous threat that terrestrial predators did. With that said, the water's edge was home to a predator that was lethal. The Rhinoceros from the tetrapod family, which living amphibians likely descended from, all the species had 4 limbs, a long tail, and body types similar to salamanders or crocodiles. The largest member of this family could be found in fresh waters, the Urancenton, a 13-foot giant that was found in South Africa. The European and Russian parts had also their fair share terrestrial predators like the Arago saw, another tetrapod species. They were more slender and narrow and not as big, reaching about 10 feet from the head to the tail. During this time, it's hard to believe that the herbivores would have been able to survive. But they did. All across the Penia, you would have stumbled across a multitude of diverse species, well more than the carnivores. The herbivores developed many survival techniques to be able to survive these times. One of the famous herbivores of this period was the Lystrosaurus, a small pig-sized diodon. The Lystrosaurus was the most common animals around. They had the most weird build. It had powerful limbs and tusk that it used to dig deep burrows that gave it much-needed protection. At least Mother Nature gave them some protection. It seems that Mother Nature mainly focused on South Africa, Russia, and parts of European countries. This is in fact true, as most of the other land masses were uninhabitable. Many were too hot. Think the desert, only twice as hot, making them prone to severe drought. If we were around 251.9 million years ago, we would have witnessed Earth become a deserted wasteland. The boundary between the Permian and the Triassic periods, the great dying part of the last Permian period, was Earth's worst extinction event that has ever happened. It's seen the extinction of 57% of biological families, 62% of genera, and 81% of marine species, and 70% of terrestrial vertebrate species. It is also the greatest known mass extinction of insects. It was the greatest of the Big Five mass extinctions of the Phanerozoic. How did it happen? Now scientists are finding buried clues to the mystery inside tiny capsules of cosmic gas. It was almost the perfect crime. Some perpetrator or perpetrators committed murder on a scale unequaled in the history of the world. They left few clues to their identity, and they buried all the evidence under layers and layers of earth. But now, the pieces are starting to come together. Scientists have suggested many possible causes for the Great Dying: severe volcanism, a nearby supernova, environmental changes wrought by the formation of a supercontinent, the devastating impact of a large asteroid, or some combination of these. Proving which theory is correct has been difficult. The trail has grown cold over the last 250 million years. Much of the evidence has been destroyed. Many paleontologists have been skeptical of the theory that an asteroid caused the extinction. Early studies of the fossil record suggested that the die-out happened gradually over millions of years, not suddenly like an impact event. But as their methods for dating the disappearance of species has improved, estimates of its duration have shrunk from millions of years to between 8,000 and 100,000 years. That's a blink of the eye in geological terms. But was an asteroid the killer, or merely an accomplice? Many scientists believe that life was already struggling when the putative space rock arrived. Our planet was in the throes of severe volcanism, in a region that is now called Siberia. 1.5 million cubic kilometers of lava flowed from an awesome fissure in the crust. For comparison, Mount St. Helens unleashed about 1 cubic kilometer of lava in 1980. Such an eruption would have scorched vast expanses of land, clouded the atmosphere with dust, and released climate-altering greenhouse gases. Weather patterns and ocean currents shifted, many coastlines and their shallow marine ecosystems vanished, sea levels dropped, drop in oxygen, and we got a mass extinction event. But despite how bad it got on land, life in the waters suffered even more due to the rising temperatures and acidification. But look at the oceans after that period. As evolutionary processes continued, marine predators became increasingly formidable. The emergence of creatures like the Mosasaurus signaled a shift, making the oceans as perilous as the lands once were. Yet during that brief window in Earth's history, the seas offered a refuge, a rare inversion where water was indeed safer than land. This extraordinary chapter in Earth's narrative serves as a testament to the ever-changing dynamics of our planet's ecosystems. It reminds us that survival often hinges on adaptability and the relentless march of evolution. Thanks for watching my short documentary. I hope you subscribe to learn